Right, well, hi everybody. Thank you so much for joining us for another Engaging Data Bytes session. Today we're going to be introducing our new partners, VaultSpeed. And the idea for this section was actually born out of a success of a previous session we did, which was focused around Data Vault 2.0. Now, some of you may have actually joined us for that session back in September, and in case you missed it, or if you're struggling with the concept of Data Vault, check out the recording as this gets started. So at Engaging Data, we've always kind of positioned ourselves as trusted experts, and we're seeing more and more work around the Data Vault methodology. So it just felt like the perfect time to showcase a great tool to help you achieve your Data Vault goals. So before we move on, and for the benefit of those that haven't joined us in the past, Engaging Data, we are the experts behind data automation. So we help deliver on data projects designed to help automate data processing and build new processes and deliver data-driven insights. So essentially, we want to help data teams discover the art of the possible and ultimately help them then deliver on that. This was actually the driving force behind data automation, which has led us to a partnership with leading technology vendors like VaultSpeed. Now, I appreciate everybody's given up a bit of their time, so we're going to jump straight into this. I have with us today Matt and Jonas from VaultSpeed, who are going to talk to us a little bit about VaultSpeed and who they are and what they do, and then we'll take some questions at the end. And that's kind of it for me for the moment. Let's just jump straight in. I'm going to pass over to Matt, who's going to get us started.
Thanks, Chris. Yeah, thanks for the intro. So my name's Matt, and I'm Regional Manager for UK Nordics for VaultSpeed, and I'm here with my colleague Jonas, who's our VP of Product Marketing. So just to give you a real quick high-level view on who we are and what we do, and sort of how we came to that point as well. So VaultSpeed started over 10 years ago. We were a consultancy carrying out implementation projects for customers, and we developed an accelerator tool to help us with that in building data vaults for our customers. And that's grown and evolved into basically what we are today. So we separated from the implementation side of the company. Now we are a software company, software solution for your data vault automation. And as you can see there, we've got a global presence. We've got customers around the globe and partners around the globe. And obviously here in the UK, our partner Engaging Data. You can see their offices. Our headquarters and where we started is in Belgium, in Leuven, just outside Brussels. We've got some of our development team in Lithuania. We've got some colleagues over in the US. Our office is Seattle-based, and UK. You've got a London office as well. A bit about what are the problems that we solve. So we find that customers have got a number of problems and why they turn to automation. Often too much manual upfront work. So you'll see during the demo where Jonas automating the code, and you'll see how much time that can save on the demo. Time for delivery in terms of actually getting that code written and deployed, but also learning new tools, and our tool's pretty intuitive, as you'll see. Technical debt, so you might have some legacy tools which are really not cut out for the right job and causing more issues. Incomplete data, and then lack of agility. These are the key things. These are the key issues that we're trying to solve for our customers. Quick example of one of our customers, so HDI, you may have heard of them, one of the big insurance companies over in the DACH region. It actually took them just 4 days between ingesting the first source into VaultSpeed and actually generating their first part of the data vault code. And now they're up to 20 sources, 386 objects. And I mean, I really like this one just because of the time between that first source ingestion and actually generating the code, because that for me is something that often takes quite a long time. But we've got customers with over thousands of objects in the data vault. So otherwise, I will pass you over to Jonas, if Jonas is ready to go ahead.
What I'll try to do today is indeed explain a little bit more about VaultSpeed and also the general approach we take to automate a lot of the workload that Matt just described and take a lot of manual work out of people's hands so that they can focus on the other important things, which is actually adding real value to your data transformation jobs. I'm going to talk a bit here about something we call abstract ETL. It's important to understand that multiple angles to data transformation. There's an integration part of it. There is also the part where you want to add business value to your data streams. So that's a bit what we're going to go through today. This is a slide that should help you guys understand where you should locate VaultSpeed within the, let's say, the modern data architecture. So on this slide, you have on the left-hand side all types of data sources. There's data and study being done out there that estimate that on average, an enterprise organization has like 115 data sources. That's a whole lot of data that needs to be integrated and from which they want to draft the value, on top of which data they want to ask questions that are where the answer is actually located in a set of those data sources, or maybe even in all of them. So in order to answer a question that has an answer that is hidden somewhere in one of these 115 data sources, you need to do a few things to make that happen. And the first is, of course, and that's where we have the extraction and the extraction load part of what is called ELT, where you get the data from a source and land it into a data repository. Data repository being the second very important component. The Snowflakes, the Databricks, the Microsofts and the Googles of this world with their very popular data platforms out there. On top of the data that you landed, you will actually perform transformation jobs, and these transformation jobs have the single purpose of adding value to the data sets that you ingested in these data repositories. If any transformation job there does not add value, you basically shouldn't do it. A very important step there to transform the data to the data elements or data products that can actually be useful for you and your organization. And then finally, on the right-hand side, we have all these stakeholders of data. You have people who do analytics. On top of it, you have people who do or feed the data back into any kind of application platform that they want to build. People that want to feed that data sets into LLMs nowadays, a very hot topic, of course. All these things, all these components, part of a general process to get more value out of your data. Now, what we've seen in recent years is that within the industry, there's a lot of automation that was put into several of these components. For example, in extraction load, if you look at a 5-tran or an Airbyte, they've built like components that can land data from a lot of different types of data sources into these modern data repositories. It's practically all no code. It's very well automated. So there's a high degree of automation there. Same for the actual data repositories. I mean, if you look at a Snowflake or a Databricks, for example, the ease with which you can set up a database in there, or a lakehouse in Databricks has become so easy. It's basically a few clicks and you have an environment set up. And then also on the way out on the analytics platforms and others, you also see increasing levels of automation there. And what we see is that while all these areas are being increasingly automated, the data transformation area is lagging a bit behind. We see that a lot of the actual work actually goes into transforming the data, and it's a bit of a paradox, yet it is the least automated component in there. Perhaps also because it's the most difficult component to automate. At VaultSpeed, we think that this is not good enough, so data transformation needs to evolve. It needs to become better in order to overcome adverse effects that can prohibit your organization from reaching its goals in terms of data. Let's automate everything. Of course, it needs to be possible, right? You need to be able to automate these patterns. There's one big prerequisite there. So if you wanna do automation in data transformation, you need repeatable patterns. So you need repeatable data transformation patterns. There's a few prerequisites there. We've written a white paper, and there's documents or videos on our website where you can dive a bit deeper, but I can go through them real quickly. So first is the fact that your objects need to be atomic. So they need to have preferably only one or as few functions as they possibly can. For example, for those of you who have some experience with Data Vault, a hub table, for example, has the function of storing the business keys. It's the most important function it has. So that object is as it is, it's very atomic. The second one is that you need an unambiguous relation between source and target. You cannot move from a source to a target and automate that entire process if you don't know the exact relationship between it. And then finally, you need to be able to use some abstract patterns. Referring again to the example of a hub table, if you know Data Vault a bit, you'll realize that a hub table practically looks the same in every occasion. So that's what we mean with abstract patterns. Some examples of repeatable data transformation patterns, or I already gave you a few, the Data Vault oriented examples, but there's many more repeatable data transformation patterns out there. A star schema to a certain level follows those three earlier principles. If you want to do a conversion of currencies, for example, euro, dollar, other currencies, other metrics that you want to convert, it's basically quite repeatable. So those patterns are also very prone to automation. And then one example that I'll maybe use in the demo later on, to calculate the age of something. You could calculate the age of a person, of a building, and so on and so on. So based on the context of the data you're looking at and based on the things you want to extract out of the data, you can actually find a lot of repeatable patterns throughout the world of data transformation. That's what I want to say with this slide. We're not going to do automation if there is no business case for it, right? So we explained what you need. This slide should explain a bit why it's useful, why it will save you time if you do automation. And we've kind of different kinds of transformation patterns here on this slide. For example, you have Data Vault, which is a highly repeatable pattern. So if you want to automate it, and you can automate a lot of objects there, the value of building an integration layer using Data Vault can be very high. Star schema as well, very repeatable. Business rules that you can use multiple times, also prone to doing automation for them. At the bottom, you have your single use business rule, probably a lesser use case for automation, because if you're going to use a certain piece of transformation logic only once, well, then there's no use in automating them. So I've put a number here. N is, if it's smaller than 10, could be 5, could be 15, could be 20, and depending on the case. But there is a certain threshold at which automation becomes interesting, at which it becomes valuable. Of course, you could also go look. I explained already that throughout data transformation, you can actually go and find where these repeatable patterns can be found. And that also means that if you use the right methodologies, that you could automate more elements or more components of your physical data runtime compared to when you use another type of methodology. Now, we say here that if you use the right methodologies, and in our case, that is first integrating the data into a Data Vault integration model, and then building business transformation logic and data marts and so on top of that integration layer. If you use that approach, then you can automate over 80% of your physical data runtime. That's a bit the message of this slide. So not every data architecture will be able to do that. But if you build a data landscape that looks like this, then you should be able to automate a whole lot of it. Let's look a bit at what we've been doing in the past. How have we been doing data transformation, and how have we introduced increasing levels of automation in doing data transformation? So if we look at Gen 1, and that's what I call the manual SQL development. Basically, what happened there is that people did SQL coding, and they were using physical data runtime components. If I write an insert into, I'm going to use the name of a table and the name of an attribute, and so on and so on. But it's really manual code writing. That obviously took a lot of time, a lot of different developers with different development styles. So we all know the drawbacks of doing manual SQL development, and people quickly saw that they needed something else. So in the second generation, what happened is that we started doing GUI-driven automation, but still using physical data runtime components. And those tools were actually what I would say the legacy or classical ETL tools. You would you would harvest or reverse engineer or whatever they called it, the metadata that you had built in your modeling tool. So you would need a separate modeling tool for that. Reverse engineer it into your ETL tool and then work with these physical data runtime components, drag and drop them onto a canvas where you could say what you wanted to do with it. And out of that, a piece of SQL code was generated. Step 2, the cool thing was that it was visual, so you could see what was happening in front of you. You could see the flow of the data with your bare eyes, so that was pretty cool. The disadvantage was, of course, that it was still like component by component, object by object. So instead of typing a lot of code, you had to drag and drop. I did a fair bit of ETL programming myself, and my arm still hurts if I think back of those days. So there were some drawbacks there as well. Then the next level for us are what we call template engines. So a template engine is basically a bit the same as in Gen 1. So you would manually code automation templates, but instead of using physical data runtime components, you would use abstract data runtime components. Referring back to Data Vault, you wouldn't be modeling the hub products. No, you would be modeling a hub and how a hub is supposed to be loaded into the raw data vault. That's what you would code inside your template. And then you would apply those templates to generate physical data runtime components out of those abstract definitions. And that's the big leap that these template engines took. So instead of building with physical data runtime elements, they used abstract data runtime elements. Yeah, that's really the first big step at really being able to build a whole lot of objects. Being able to integrate a whole lot of things. You would ask yourself, well, what is Gen 4 then? We see the question mark over there. For us, Gen 4, well, it's simple. So we already had coding, we already had GUI driven. We talked about the difference between working with physical and abstract data runtime components. Well, in Gen 4, you would have a GUI driven approach using those abstract data runtime components. And it would really be about, again, working with abstractions of what we see in our physical runtime. So I would say the source table of products has a key and identifier, which is the product ID. Then I wouldn't work in my template. I wouldn't work with template ID. I would work with business key, because that's the abstract component. Now, if you want to visualize that, you have to work with something which we call, you would again first have to collect all the metadata, all the metadata that you can get from those physical data sources. Very similar to what the legacy ETL tools were doing. But you wouldn't just start working with these physical components. No, you would first actually tag your physical data components according to what we call abstract signatures, so abstract components. Let's say that product ID, I would tag it as a business key. The customer ID, again, I would tag it as a business key. And then there would be a template which we call an automation template that defines the transformation logic on the level of those abstract objects and attributes. So for example, a business key, well, if I want to load a hub table, the hub table will describe what I want to do with that business key in order to load it, to generate the code for it that I can push back down to my physical data runtime. And that's a bit how abstraction works. You look at it, you try to get as many metadata in as possible. You make abstraction of that metadata. You pour these categories or metadata components, you pour them into automation templates that will eventually generate, again, physical runtime code for first your integration layer, and then secondly, also your business layer. Now in VaultSpeed, and then I'll get to actually showing VaultSpeed, but I first want to explain you a bit more about how it actually works. So VaultSpeed has a few key components to make this automated data transformation work. And the first component is a metadata repository. That's a metadata repository that can store all the metadata from your source systems with minimal effort, of course. It's capable of grouping these metadata objects in those signature groups to be able to make those abstractions real easily. And then finally, once you've harvested the metadata, it can already make a few assumptions based on the metadata that you have. I'll show that in a minute in the demo, what I mean by that. Next component on top is a GUI, a graphical user interface. And that user interface is what really explains the metadata to a user in a visual way. So instead of looking at a bunch of code scripts and coded templates, you would actually be looking at a graphical user interface that allows you to harvest, so select and collect your metadata, that puts a data modeling proposal on your screen, and then allows you to change that model and basically enrich the metadata that was delivered in the first run where you harvested it. If you do enough of that enrichment, and that means you will either accept, correct, or enhance the data model proposal that was delivered to you. If you do enough of that modeling, enough of that process, you actually end up with a metadata set that is then ready to generate code according to your needs. And the way to do that is by feeding all that metadata, all that enhanced and enriched metadata into predefined automation templates that can then generate the actual runtime code for you. Final component or final two components of that are that we've built a solution for this with these three core components, but we've also built it in a cloud architecture that ensures that all the learnings, all the support for all types of different use cases and edge cases, they're all supported within the tool. So whenever we update that template set here, that knowledge is actually automatically spread across our entire customer base. That's a very important reason, or the main reason why we wanted to build it as a SaaS, a cloud native product. And of course, you need to be able to push so you need to be able to harvest your metadata. You need to be able to push the code that was generated into your actual runtime. We do that by having a local lightweight agent where it's a bit of a hybrid setup to get a secure connection to harvest metadata and push the code artifacts back into your physical data runtime. Here is VaultSpeed, and I went directly here to the screen of the sources. So you can set your projects and your system parameters and stuff. But the cool thing is it's all about ingesting metadata from different sources. So this is the screen where you can create a source, click on that source and go to a specific source release. You can pick one here. You see I've made 3 completed versions of my source, and I created a new version here, which is basically a version that allows me, it's still unlocked, so it hasn't been saved, that allows me to play around with it a bit and show you guys what we mean by integrating sources and having a data modeler to do the interaction with the metadata that is presented to you. So if I clean this up a little bit, then you see that based on the metadata that I harvested in VaultSpeed, a data model has been shown to me. And then the actual process of interacting with that data model is nothing more than selecting which signature object. So you can see which ones they are. They are all around the concept of data vault, because that's what we use. That's the methodology we use to build your data integration layer. But you can see that they're all here. So whether it's a satellite or a many-to-many link or a reference table, depending on the actual needs, you can give some more input to the model that was proposed to you. So if I don't agree with VaultSpeed that this bicycle table here should be modeled as a hub and satellite, I can very easily change that in this modeling interface. That's on the object level. You can do the same for the actual attributes. So let's say here I have let me zoom in a little bit. I have a customer table. Somebody indicated here, or VaultSpeed indicated, that this natural person ID is probably the business key. Well, in this case it is, but if I don't agree and I think that the person number should actually be the business key, I can also very easily change that and tag it accordingly. So in that case, I would click this business key from the menu, set it as the correct option, and let me do that maybe, and then it will change, or it will become part of the business key. Let's say I don't want this one to be the business key anymore, should just be a descriptive attribute. There we go. And now I've changed that configuration. So I've interacted with the data model, and in that way I've interacted with my metadata repository. I changed the abstract signature grouping for this object or for this attribute, and the actual metadata will be treated accordingly when they are pushed through the automation templates. So that will influence the actual physical runtime code that is generated when I would deploy this into my physical data runtime. Now, if you've done enough of the modeling for all different sources you want to integrate, you can actually start integrating those data sources into what we call the integration layer, and that is entirely modeled using Data Vault. So I've built a Data Vault right here. I included my two sources. This is a cool screen because this is where you can see how we built the integrations here. In my sources tables that contain data about bicycles, electric bicycles, cars, we all agreed that within our business, these different objects are to be categorized as products. So we centered them around a central product hub where we gather all the information within these different data sources around our product inventory or product portfolio. And the same thing is I did that for the shops as well. So there's data about the shops or the dealership that we have within our organization, data that comes from the sales source, data that comes from the product source. We also chose to center that around one central hub. And that's a bit how you do integration with VaultSpeed. And if you again did enough of those integrations, you can move into what we call a graphical overview, and you will end up with a data integration model that looks a bit like this. So you can see here, for example, I have all the data around products gathered together. I have my customer data as well. I have a relationship between who bought which product. So it's pretty clear to see the actual business model from this Data Vault model. And somebody that understands how the business works will also understand this Data Vault model or this integration model. So that was the first step, where you have the data integration process. Then you end up with an integration layer. And on top of that integration layer, you can then start building what we call business logic, business artifacts. And in order to do that, you need what we call our business vault, where you can easily see the names here. So Data Vault, Business Vault, that's the natural flow within VaultSpeed. So if we dive a bit deeper into the Business Vault, we select the Data Vault on top of which we build it. We select our Data Vault release, and then we can build as many Business Vault releases as we want. And in order to show you what we will use as the basis on top of which we are going to build this Business Vault, I deployed my Data Vault into Databricks. Could have done it in Snowflake or any other platform, but I've chosen this platform now. Often like to change it a bit. That keeps things interesting for us as well. And here you can see that I deployed the entire Data Vault. The model that I showed you a few seconds ago is deployed here as actual tables that are installed on my Databricks runtime. I can select here a specific table, the one that contains the addresses data, and show you some sample data. So that was all loaded. Maybe not the most interesting one. So if you look at, let's see, the customer data, for example, where is it? Here you go. So this data set was loaded into our integration layer from our sales source, and it contains the data, the general data, not the GDPR sensitive data about our customers. And what we want to do now is, we want to try and make sense of this Data Vault model. Not everybody understands how this integration model works. Not everybody needs to understand it. But what we also want to do, of course, is to build some artifacts on top of this integration layer that make it much more easy to use for anyone within the organization, basically. So what I wanted to do is to show you how you can very quickly build with VaultSpeed some objects that can help you to extract the data from that integration layer. First object type is a point-in-time table. Point-in-time table is I would call it a helper table, something like that, to quickly make sense of a hub and the different satellites that float around that hub, and find a way to quickly present the data to an end user. And then the second type of object is what we call a bridge table. And so this is a bridge table, a table that basically bridges, in this case, the gap between products and customers. You could build much bigger bridge tables, but I've built a simple one just for you guys to be able to understand. So those two objects will help me get the data out of my data vault a lot faster and a lot easier. And then finally, and this is where you can actually start building additional business logic. Come on, yeah, here it is. So here I've built my own custom automation template. And let me quickly show you how I did that. So my own custom automation template, where I've built a dimension on top of the point-in-time table that I just constructed. And that will help me to very quickly actually create some business artifacts on top of the raw data vault, so that not everybody has to care about how this data vault works. They can just play with the tables I automated and built in these in this March schema. So I applied the automation template that I built on top of my customer and product objects. So let me quickly show you the dimension table for the customers. So there's some sample data in there as well. This basically contains data from all the different satellites or that we had around the customers, so from the different sources. Same thing for the products. So remember we had a lot of product satellites. So in this table, they would all be centralized in one dimension where you can easily find the data from these different sources, all integrated into one big dimension table. So quite easy to use, and also quite useful if you want to make, for example, some reports on top of that. So here I've built a report. It uses my 2-dimension tables, and it also uses my bridge table, so my purchased products table here, basically just to see which customers bought which types of products. So I can see that I have one or a few people here who bought at least 2 or 3 different product types from my shop or from my dealerships, whatever. This guy bought a car. He bought 3 motorbikes and a bicycle. So that's a pretty good customer, I would say. And that has all been constructed with automation templates. So I didn't have to write any manual piece of code here. I used the automation templates that are embedded in VaultSpeed for Data Vault, and I used an automation template that I downloaded from our community page to build a dimension object. Now, maybe see how much time we have left. Yeah, let's quickly do this. So the cool thing is that I've built a table here for my customers, and you can see that there are 2 fields in here. One which contains a birth date, and the other one contains the first purchase date. So the date at which a customer did his or her first purchase at our company. What I don't have is a field that calculates first the age of the person, and then let's say also the age of the customer. So how long has he been a customer? Would be pretty cool if I could calculate a field real quickly and automate that into this dimension. So what I've prepared already here is, and you can see that this dimension is basically a join of my hub table, my pit table, and my different satellite tables. That's basically how it works. You can see how that is constructed. What I added here was an automated attribute, and I've called it the number of years since start. And start could be anything. Start is an abstract signature attribute that I applied on first the birth date field, and second I also applied this signature on the first purchase date. And by applying that signature and then using the signature to construct another piece of logic on top of it, I can actually automate these two, let's say, age fields that I wanted to calculate into my dimension. I've already ran a preview here. So these are two fields that will be added. I will have one field that contains the number of years since birth date, so the person's age. A second field that will contain the number of years since first purchase. Now in this example, my use case for automation is perhaps a bit low. I only have two instances, so I wrote one piece of code to generate two fields, but you can imagine the more age fields or the more date fields I have in my integration layer, the more places I can apply this template. So what I will do now is quickly deploy, where is it here? So this is the automated deployment screen. I can actually deploy that latest version of the automation template into my Databricks environment, and then it will take a while. So if I refresh this, you can see now that this thing is actually deploying. You can have a look also in my task screen in VaultSpeed. What the progress actually is. By the way, this task flow, everything you do in VaultSpeed, every process that you start, whether it is harvesting metadata, deploying code into your runtime, or constructing a new source release, data vault release, everything that would take some time, every process that takes a bit of time to complete is automatically added to this task queue where you can await its completion, or you could just go and have a look around in VaultSpeed and do something else, some other useful work. So the way that VaultSpeed works is that the task queue is you can see it's done now, but the task queue is really what covers everything that needs to happen. Also in communication with the local agent, but nothing more. All right, we can see that it should have been deployed now. And whoops, log back in. Here we go. March. So it should, I hope it worked. Here you go. Now you have these fields here, number of years since start, number of years since first purchase, and it should contain the actual number of years. So this is a person that's 30 years old, 41 years old, and the first one has been a customer since 3 years, the other one since 1 and 5 years. So that's a bit what we added to our dimension, and it was as easy as that. So I quickly created a new art attribute. I used the same logic to apply it on 2 different instances and deployed it into my runtime, where I'm now able to use it and query it and build reports on top of it. That concludes my my demo. Like to explain still is that a few things you saw here. So actually VaultSpeed, we did 2 things combined, right? We did some modeling, some relational modeling. We had an interaction with our source model, and based on that we created a model for the integration layer, while at the same time also building all the transformational logic, which is embedded in the automation templates. Instead of doing these 2 things in 2 different tools, you can actually get both at the same time with VaultSpeed. First important thing to remember about our tool. Second important thing is, of course, this is the we tried to estimate. Of course, we didn't hand code this entire example. That would take way too long, as you can see. But based on how many lines of code were actually generated to build this runtime, and then the amount of time it takes an average developer to develop a certain number of lines of code, you would say that if you would hand code this, it would take you 70 days to do it. With VaultSpeed, apart from the fact that you have to do the functional and technical analysis and the business analysis, of course, that takes the same in every different type of the evolutional ladder. The other stuff really takes you only a few hours if you really want to do it right. And that's I think the best proof that that automation really has a lot of business value. The more sources you need to integrate, the better the use case will become. And then some final key points I want you to take away. So VaultSpeed is data model driven. It's always trying to show you the data vault. The way it does that is because it has a GUI that can do that, a graphical user interface where you can interact with the data models. And then finally, we have two kinds of integration templates, or two kinds of templates. The first ones are there to build your integration layer based on the data vault methodology. And then the other templates are the ones you can actually build yourself and share with others. And that's where you can apply your business templates, your business logic.
Yeah, well, thanks, guys. And thanks for the great overview, Jonas. I think that was really helpful. We'll jump straight into some Q&A. If you've got any questions and you haven't yet done so, stick them in the comments. I do have one that's already locked and loaded for you. Is VaultSpeed involved in the actual runtime of the data? Is it a runtime component?
No, that's a good question indeed, because sometimes people didn't fully get that one. So this is a good slide to show that. So yeah, you should imagine VaultSpeed as being a tool that helps you develop your runtime faster. We're not in that runtime, so we are not a component that actually loads any data. We don't touch your data, by the way. We only use the metadata in order to create all these data models for the integration layer, for the business layer. So yeah, to make it short, we're not in the data runtime. We just help you to build it a lot faster.
Okay, no, that's great. I'm not seeing any more questions in the chat for now, so I think that means you've done a stellar job on the demo. I just wanted to say a big thank you to everyone that's joined us today. I hope you've all found today's session as useful as I have. And obviously a big thank you to Jonas and Matt from VaultSpeed for a great demo and presentation. We're going to be doing a lot more of these, so please keep your eyes peeled for invites. And if there are any subjects or topics you'd like to see us talk about, please let us know.